Turn a steering wheel and a tiny steel bar inside the column twists just 4 degrees. That twist is the whole secret. It's how the car decides how hard to push for you. Here's the trick your car pulls off. At a parking spot, the wheel turns with a fingertip. On the highway, it feels firm and planted. Get that balance wrong and steering is either dangerously twitchy or exhausting. So the car can't guess how hard you want to turn. It has to actually measure your intent. Start with the old way. For decades, cars used hydraulic steering. A belt off the engine spun a pump that kept fluid under pressure all the time. That pressure did the heavy lifting when you turned. But here's the waste. The pump ran even when you were driving dead straight, sipping engine power for nothing, hour after hour. Electric power steering throws the pump out entirely. In its place sits an electric motor that stays quiet until the moment you actually need help, then pushes. That alone saves fuel. A motor, though, is dumb. It can shove hard or gently, but it has no idea which you want. It needs a signal, a single instruction telling it how much muscle to add right now. And that instruction has to come from you. Which lands us on the real question, the one this whole system is built to answer. How does the car know how hard you're pushing on the wheel? Not roughly. Precisely many times a second while you're mid-turn. You never press a button or set a level. So the effort of your own hands has to become a number the machine can read. The answer hides in one clever part. Between your hands and the front wheels, the steering column isn't one solid shaft. It's cut in two. The upper half connects to your hands. The lower half connects down to the wheels. Bridging that gap is a deliberately thin steel rod called the torsion bar. Because it's thin, it does something a fat shaft never would. It twists. Push the wheel gently and it twists a hair. Wrestle it hard and it twists more. The harder your hands work, the more that little bar winds up, like the last inch of a wrung-out towel. And this is engineered, not accidental. The bar is tuned to twist only about 4 degrees at your maximum effort. 4 degrees is barely more than the tick between 2 minutes on a clock face. Right at that limit, a mechanical stop inside the column catches, and the two halves lock together as one solid piece. So you never keep twisting into nothing. Even if every electronic part died, that hard stop means your hands still turn the wheels directly. But a twist you can't even see is useless on its own. Something has to be watching it closely enough to catch 4 degrees. That watcher is the torque sensor, and it sits right on the torsion bar. Its only job is to measure the twist between the two ends. Most designs read it magnetically. A little ring of magnets rides on one half of the shaft in a Hall effect sensor. A chip that reports how strong a magnetic field is sits on the other half. When the bar twists, the two ends fall slightly out of alignment. The magnetic field the chip sees shifts. The sensor turns that shift into a voltage. Gentle twist, small voltage. Hard twist, bigger voltage. So 4 degrees of physical flex becomes a smooth electrical signal that climbs and falls exactly with the effort of your hands. And that is the number the entire system runs on. Not your speed, not your steering angle. Just this: how hard and which way are you trying to turn right this instant. Read hundreds of times every second. Here's why that matters so much. The car isn't inferring your intent from where the wheel is pointing. It's reading the strain in your hands as it happens. But knowing how hard you're pushing is only half the job. The same push should mean different things at 5 miles an hour and at 70. Now the brain steps in. A small computer, the ECU, takes 2 inputs. One is that torque signal, how hard you're pushing. The other is how fast the car is moving, straight off the speedometer wiring. It blends them and commands the assist motor. The rule it follows is called the assist curve, and it's the reason the wheel feels so different at different speeds. Creeping through a parking lot, the computer pours on help, so a fingertip swings the wheel lock to lock. As you speed up, it deliberately backs the help off. On the highway, it adds only a light touch, so the car feels steady and doesn't dart at every twitch of your hands. Same twist from you, very different push from the motor, decided entirely by speed. And here's the elegant part. The motor drives a gear, either on the column or on the steering rack down below, and it always adds its force in the exact direction you're already turning. It never steers for you. It just amplifies you, matching your effort a few hundred times a second. That's why parking feels effortless, yet you never feel like a passenger. Your hands still set the direction. The motor only makes it lighter. Trace it all now and the whole loop appears. So here's the full chain end to end. Your hands push the wheel. The thin torsion bar twists up to 4 degrees. The sensor reads that twist as a rising voltage. The ECU blends that voltage with your speed. The motor adds a matching push in your direction. All of it hundreds of times a second while you just drive. That's why the title is 1 bar 4 degrees. The entire feel of steering a 2-ton car, every ounce of effort, comes down to measuring one tiny mechanical flex. A whole sensation reduced to a number over and over. And this is the part that changed cars forever. Once the motor can push on command from a signal, the signal no longer has to come from your hands. Feed it from software instead and the car can steer itself. That single shift is what quietly made lane keeping and self-parking possible. The moment your effort became a number, the car gained the ability to add effort that isn't yours. So the next time steering feels effortless, remember what's really happening. A steel bar the width of a pencil is twisting 4 degrees, and that tiny flex is how your car reads exactly what you want. Next question, what happens when engineers cut the steel link entirely and let wires do the steering? That's steer-by-wire and it's already on the road.